All right, here's a 3-2 video. Here, our goal is to perform function operations. And if you think about your operations, addition, subtraction, multiplication, division, I can't talk today. Addition, subtraction, multiplication, and division. That is function addition, function subtraction, function multiplication, function division. So here I want to say it a little bit kind of differently. What we're going to do is we're going to take two functions, and I want to show you kind of how we write them. So we're going to do add, subtract, multiply, divide. So let's take a look at the different operations, and then we're going to make a little chart here. And how we write it in math. So I'm going to write it like this. We say, right, so the first operation, if I had an f of x, and mind you, f of x and g of x, they're going to be given to you, and then you're going to be asked to do something with it. So here, we're going to take a look at f of x plus g of x, and it's written in math, we would write that as f plus g, so it would look like this. So anytime you're given something that looks like this, you could rewrite it as f of x plus g of x as two separate things, but here it's really written as one big thing. And the same thing goes for subtraction, f of x minus g of x. We would write that as f minus g at x. And then multiplication, if I have f of x and I'm going to multiply that with g of x, we'd rewrite that as f times g at x. And then with division, if I'm going to divide, I really don't like using this symbol here, but that's okay. We would write it as f divided by g at x. And that's really the basis of it. What I can say, though, I really want to write this out like this. Note, or I would even call it a hint. Use parentheses. You're going to use them a lot. And here's what I mean by that. Let's take a look at our very first example here that they're going to give us. All right, so the first example says, here f of x is x plus 4. G of x is x squared plus 5x minus 2. And it tells us to find f plus g at x. Let's see if I can get that to focus any better. All right. So f plus g at x. Now, you don't have to write this middle step every time, but I want you to see that this is just simply f of x plus g of x, right? You don't have to write this every time. In fact, I almost don't want you to write that every time. So what I'm going to do is I'm going to take f of x and then I'm going to add g of x with it. Well, f of x, so I'm going to write this whole thing out in one statement here. F plus g at x is f of x. So here we have x plus 4 plus g of x, which is x squared plus 5x minus 2. And now here we're looking at polynomial addition. Polynomial addition, remember, all you got to do is combine your like terms. So here we're left with, again, I want this in standard form. So I'm looking for the largest exponent. I only have one x squared here. 5x plus x would give me 6x. And a 4 and a negative 2 is 2. So f plus g at x is x squared plus 6x plus 2. And that is it. Now let's take a look at what happens with f of x minus g of x. Let's find. Let's take a look at another example here. All right, so again, this is f of x minus g of x. Well, I'm going to start with f of x, which is 6x minus 7. You notice how I'm using my parentheses. This whole thing minus this whole thing, which we get nx squared plus 2x minus 1. And now I'm subtracting. There are college students across the world that do not realize that I have to distribute this negative. So don't be that kid. You have to distribute the negative here. So I'm going to drop the parentheses on the first polynomial, the first function. This guy, he does not change at all. But a positive x squared times a negative 1 would become a negative x squared. A positive 2x times negative 1 is a minus 2x. Negative 1 and negative 1 is a positive 1. Now I want to combine my like terms. Starting with the largest exponent, I have a negative x squared. 6x minus 2x is a positive 4x. And negative 7 and a positive 1 is a negative 6. So f minus g of x is negative x squared plus 4x minus 6. Let's take a look at a couple more examples. What about multiplication? Same thing. I want to use parentheses, so here I'm going to have the f of x, which is 2x plus 1, times g of x, and here g of x is x squared minus 3x plus 7. Notice that I don't have to put the operation in between these two because it's understood that parentheses backed up against another set of parentheses, this is multiplication. So now I'm going to distribute the 2x to each term, and then I'm going to distribute the 1 to each term, combine my like terms, and I'm good. So here, 2x times x squared is 2x to the third. 2x times a negative 3x is a negative 6x squared. 2x times 7 is a positive 14x. Now distribute the 1. 1 times x squared is x squared. 1 times negative 3x is a negative 3x. 1 times 7 is 7. And now I just got to combine my like terms. Starting with the largest exponent, I have 2x to the third. A negative 6x squared plus 1x squared is minus 5x squareds. 14x's minus 3x's is a positive 11x. And then just the 7. And that is as far as I can take it. And now the one that might draw the most confusion, but it's quite possibly the easiest of the bunch. Now, f divided by g at x, here we go. F is 3x squared plus 7x minus 12 divided by g of x, which is 2x squared minus 4x plus 1. And I'm done. And that's it. If I could factor, I may factor if I can. Try and see if anything cancels, but in general, you're just going to take the first function, divide it by the second function, and that's it. That's as far as I got to take it with this guy. All right. So now, I want to take a look at function combinations for a specific value. And here we have two different methods. I'm going to go over both methods, and I want you to see which one works best for you. But know and understand that you can use either one anytime, okay? So the first method is to find each individually and then perform the operation. Here's what I mean by that. F plus G at 3. What I'm going to do is I'm going to find F at 3 and then add that with G at 3. And so the function they gave us, f of x equals 2x plus 1, g of x equals 4x minus 7. So f at 3 is 2 times 3 plus 1, which is 6 plus 1. That gives me 7. G at 3, g of 3 is 4 times 3 minus 7, 12 minus 7, which is 5. And now f plus g at 3, f of 3 was 7, g of 3 was 5, 7 plus 5 is 12. And I'm done. The other way to do this, same exact example, same exact numbers, is I'm going to find f plus g at x first. So f plus g at x, well, that's going to be 2x plus 1 plus 4x minus 7. And this is f plus g at x. So, and I add these together, and 2x plus 4x gives me 6x. 1 and negative 7 is minus 6. So this is f plus g at x, f plus g at x. And now f plus g at 3 is going to be 6 times 3 minus 6, which is 18 minus 6, which is 12. Sorry, I ran off the board. My bad. Sorry, I ran off the board. Okay, so just to make a clear distinction between these two things. One, the first method over here, I find f plus 3 by itself. I find g of 3 by itself, and then I add those things together. Or perform the operation, whatever the operation. This one happened to be addition, right? The other method is f plus g at x first, and then plug in the 3 and find the value at that point. Either way you do it is just fine, and really the work is symmetric, so there's not a whole lot one way or the other.